This is a tutorial on how to do graphs and use Excel for data analysis in labs. So let's say we had this data, the mass and volume data for aluminum and lead. And so first thing to do is to set up a table, and we can fix up the table. For instance, maybe I want lead to merge and center, since both of these mass and volume readings refer to lead. Same thing for aluminum. If I'd like to clean this up, I could put some lines in there. There we go. Now, if I'm going to make a graph for this data, so once we get the data all typed out like this, we can highlight it and then go to Insert. And in science, we typically use scatter graphs to analyze the relationships between two variables. So go to Scatter, and the best one is usually either this one with just the points, or sometimes we'll use the ones with the points and the lines between it. But in this case, I'm going to use just the one with the points because I'll be adding a trend line later, and I don't want those other lines to clutter it up. Well, the graph didn't turn out the way I wanted it to turn out, and that's usually the case with more complicated data sets like this. Graphs work pretty well with that automatic feature if there's just one thing for the y-axis, one thing for the x-axis. But I'm going to need to clean this up. So to clean it up, I'll need to go to, so click on the graph first of all. If you're not on the graph, then the graph menu features don't show up here. So you click on it, and then the chart tools show up at the top. And click on the Design tab, then go to Select Data. And now I can manually select the X and Y data. So I'm just going to delete all this, and I'm going to add a series for aluminum and one for lead. And so I can manually select the X values. For this graph, we're plotting mass over volume, mass on the y-axis, volume on the x-axis, so I'm going to select volume for the x-axis, then just press enter. The y values, click on that button, highlight the mass, press enter, and then just click OK. So now I do the same thing for lead. Select the x values, that's the volume, and select the y values, and press OK, and press OK, and there we go. So it looks like we have one data point that's way real outlier. I'm going to delete that point actually. Oops, didn't mean to do that. So we have here a volume of 8. Let's just get rid of that. There we go. So it's easy to clean things up here when we use the program. So scientific graphs need labels, and so we need to add a y-axis. So to do that, once again, click on the graph, go to Layout, go to Axis Titles, and go to Primary Horizontal Title. Or we'll do vertical title, I guess, first. I usually prefer the rotated tile, and so now I can type in what the y-axis is. So that's the mass, and the unit is grams. Usually we would put that unit here in the table as well. The volume unit is milliliters. Oh, and by the way, if you want to resize something on Excel, you just double click right there and it will automatically resize. So then we need to add the x-axis as well. So we click on the graph, go to Layout, go to Axis Titles, Horizontal Tile, and type in the volume and the unit. We need a chart title as well. So back to layout again, chart title. And so it's whatever's on the y-axis, so the mass, versus whatever's on the x-axis. And we can resize the graph as we want to. Now we'll need to add trend lines for this data. So we click on the graph and then go up here to layout, find trend line. Now you could just click linear since we have a linear relationship, but in order to display the equation we'll need to go to more trend line options. And so we choose which one and choose which type of graph or which type of trend line. So sometimes we may use some of these other trend lines as well. So it's not always linear, but this is a clear linear relationship, so we want a linear graph. And then so we find the button right here that says display equation on chart. And so there's the equation for aluminum in point slope form. We'll need to do the same thing now for lead. Alright, so select lead, linear, display equation on chart. And so, oops, I did the wrong one. It's r squared value. Try that again. Alright, so now we have the equation for both of those, and we could get the slope from this as well, from this equation. Now, sometimes we will be printing these graphs, so the best way to print the graph, let me show you, if you just go straight to print, so go up here, print, here let's do the print preview. See what it does? It cuts the graph halfway off the page. Yeah, that doesn't look very good at all. So here's a better way to do it. Click on the graph and then go to print. So then it automatically sizes it to fit the page and everything comes out clean that way. Alright, so that looks like a good graph. Let me show you some other cool things that we can do with Excel. So when doing data analysis, we can really save a lot of time by using the functions of equations in Excel. So let's say I wanted a class average for the mass and volume data here. Alright, so I could press equals, and now I can make any equation I want. So you can do math problems. Let's say I want to do 2 plus 2. You just type it in, and there we go. So you can do any sort of math problem you want, press equals, and you can enter formulas. So let's say I want to average all of this. Well, I could, you see, you can select things. You can say this plus this plus this, and then divide by the number of entries there and find the average. So that would be the long way to do it. But there's lots of formulas in Excel, like the sum formula equals SUM. And the formula, when you enter a formula, you always type in the formula, then parentheses, and you select the data, then close the parentheses, and then enter. There's the sum. I could put in the number of entries here, and that's another formula called count. Equals count, parentheses, and then I could find the average by doing the sum divided by the number of entries. Alright, so that would be one way to find the average. Here's a much faster way to find the average. Use the average function. And there we go. Now, there's lots of other functions. If you click on FX here, you can find them by categories or go into all the different types of functions on here. There's a tremendous amount that can be done with these functions, so you can always look it up if you're not sure what the formula is, but some of the most common ones are shown here. One of my favorite functions is the if-then function. I use this for all kinds of things whenever I'm analyzing various assignments and data. Like, let's say I only want data that's above, for the mass that's above 5 grams for lead. So I could do an if-then function, equals if, and so I select equals if this is greater than the number 5, then display the number, otherwise do nothing. Close parentheses, enter. And then I can fill that function down by dragging this little plus sign thing on the corner, fill my function down, and there we go. So that's a really cool way to filter out data. So anything that is above 5 now is showing up, and everything that's not. So it's a very powerful tool. There's a lot of things we can do when analyzing with that function. You can either even pick out a range, for instance, like if equals if, and you can add multiple functions together, and it's greater than 5, and so let's put in 2 different conditions. Here, we'll restart that. Equals if, and this value is greater than 5, comma, the cell here is less than, how about 7, close parentheses. Now we put in the result of the if-then function. If that's the case, then let's say it's going to display, how about a text value? Like, I don't know. Otherwise, we can say put in quotes. So then we can fill that down, and so it filters out the one entry that was within that range. You could also change that. Instead of text, you could put in numbers, like this number is 3, or this number is 5, or whatever it is. So we get the 3 only on the 1 there. So there's tons of things we can do. Now for some labs, we might have some other types of information here. So let's take a look at this data, for example. We have time and concentration shown here. So let's say that I want to make a graph of this. So I highlight all the way down, go to Insert, Scatter, and this one came out pretty clean because we only had one series here. So we wanted the concentration on the y-axis and the time on the x-axis, so that's came out the way we wanted it. We would want to clean up the graph and add the axes. Let's take a look at how to do that again. Go to Layout, Axis Titles. So here we have time, and then we have Axis Titles, horizontal, vertical, and concentration in molar. And of course we change the title. So it's clear here we have an exponential type of relationship. And often in science, we like linear relationships whenever possible. They're a little easier to deal with mathematically. So let's say we wanted to do some other calculations for this data to turn this into a linear relationship. Well, let me back up 1 second here. Let's see that you can also add trend lines for this relationship. You just have to pick the right kind of trend line. So I could go up here to Layout, Trend Line, and looks like we have an exponential relationship. Go to More Trend Line Options, Exponential, Display Equation, and there we go. So we have our equation or trend line that fits this data here. But we could also turn this into a linear relationship. So I'm going to click and add a column here. So there's a couple ways to do that. You can click and go to Insert, Insert Sheet Column. And I'm going to plot 1 over the time, which is the same thing as the rate. So now I can do a formula. Instead of having to calculate it every time, I just do equals this divided by, equals 1 divided by the time. It's not going to work for 0. It should work for the others here. And we just fill that all the way down. Now, maybe I want to take out all those decimal values. So I could do, go up here, go to Format Cells, and go to Number, and limit the decimal places to 2, so it automatically rounds for me. So now I can do the graph of these values here. Highlight all of that. And I just press Control and highlighted those. We'll see if it pulls up those as the headings. Alright, so that didn't quite work out for us in terms of getting a linear relationship. So maybe I want to play around with some other types of relationships. Maybe I could try doing, instead of 1 over t, I could try doing a log function, like the log of t. So we can look up the log function in here if we're not sure what it is. Log parentheses, select that number. There we go. Fill it down. Okay, well that didn't give me what I wanted. Maybe I could do instead the negative log. So we could keep messing around with these types of things until we get the formula that we want, a linear type of relationship for the data that we're dealing with, or whatever we're trying to look for. A few more things about doing the formulas. So keep in mind order of operations when you're typing in numbers. So if you're doing 2 plus 2, and then you want to multiply it by something, you put that in parentheses, of course. And also scientific notation, you can type it in with an E. So if we wanted to put in Avogadro's number, 6.02 times 10 to the 23rd, 6.02 E 23. Or if we wanted a negative exponent, like 0.000123, we could put that in as 1.23 E, count those zeros, 1, 2, 3, 4, 5, e negative 5. Oops, I put the wrong thing. E negative 5. I think these are the main things that will be helpful with setting up graphs and using the equations. So thanks for watching, and hope it helps.